if you are someone who is struggling in your current PU2 class because you have missed some of the concepts from your PU1 classes and some important concepts are yet to be taught in your mathematics class, then definitely this is the video you must watch, right? So welcome to Deeksha Karnataka YouTube channel, and here in the bridge course part 2 I am going to discuss two very important concepts, calculus and graphs. And if you are watching our channel for the first time, then definitely you have to subscribe to our channel because it will be helpful throughout your PU2 journey, including your competitive exams, board exams, etc. Everything will be covered in our channel only, right, and absolutely free of cost. Now if you are obviously struggling in your PU2, you must watch our part 1 of the bridge course as well. The link of the part 1 bridge course is given in the description as well as in the comment. You can go and check that out. Also this is the part 2 where the most important concepts of calculus and graphs we are going to discuss in this session. Now calculus you have done a bit in your PU1 lectures, but if you have missed it, then don't worry, I will be covering all the important concepts including integration, differentiation, functions, etc. So let's look into the chapter wise coverage for today's lecture. So in the part 1 of the lecture we have covered trigonometry, trigonometry, Pythagoras theorem, ratio of angles, degree to radians, formula list. In algebra portion we have covered quadratic equation, binomial expansion and common formulas. Today I am going to cover calculus, functions, differentiation and integration, and in the graphs and geometry section we will be covering straight lines, circles and ellipse, parabola and hyperbola, graph, geometry formula, etc. So these are the these two topics we will be covering today. Okay, these two topics are already covered in our part 1 of the lecture, right? So let's start with the first concept, that is calculus, right? So many students suffer a lot because they do not have basic idea about calculus. So don't worry too much in detail. You will learn in mathematics some part you have already learned, some more parts you will study in your mathematics class, but let us start with the basics. Basics of calculus is functions. Okay, function means it can be anything. Whenever you can write one variable in terms of some other variables, it is considered to be a function. For example, if I say 2x plus 3y equals to 7, is it a function? Yes, it is also a function. You can write 3y equals to 7 minus 2x or y equals to 7 minus 2x by 3. This is also a function. Okay, in physics functions are not that simple. Generally it is given, for example I am giving you one example. E equals to say 3x square I cap plus 2x j cap plus 3k cap. This is also a function. This can also be considered as a function based on what quantity you are studying, based on what type of quantity it is. It's a vector quantity. Okay, it can be a vector function, it can be a scalar function. It is also a function. Okay, so in physics it is basically little bit complicated as the functions are not always simple. It can be complex function as well. Complex function not in terms of complex number function. Complex function means little bit difficult to understand function. Okay, and generally we do not use y is equal to function of x. We generally have physical quantities, for example here electric field, in terms of distance, right? In other cases you will find time function as well. So based on time you may have seen some kind of function x square equals to 3t cube plus 4t square plus 3t plus 2, right? This kind of functions you have seen in your PU1 class as well. This is just an example, right? So functions can be little tricky, can be little difficult, but here one side we have one variable, other side we have another variable, then obviously it's a function, right? And there are some conditions of the functions based on the differentiability of the function, integrability of the function, but we are not going to discuss all those complexities. In general physics means in your PU2 classes, functions are always continuous functions, so that we will assume it, okay. In some cases, if they give you some conditions, you can keep that condition in mind, but you always have to remember that functions are generally always continuous in physics, unless some of the advanced physics level concept, that is if you are preparing for advanced JEE, then maybe you need to consider some functions which are not continuous as well. Now let's see, first we will start with differentiation. Okay, here we have a v versus time graph, okay, and the graph is a straight line. So graph is a straight line graph, and if I ask you what is the slope of this graph, what is the meaning of slope? Slope means if this is the angle theta, okay, then slope is basically given by m equals to tan theta. Now if it is a straight line graph, you take any point. We have taken this point, you can take any point on this line, okay, you measure the x coordinate, okay, say this is time t, and you measure the y coordinate, say this is coordinate y is v. This is a velocity versus time graph, right? So this is the y coordinate, the difference, okay, the value v, okay, if this is the this point is 0 comma v, this point is t comma 0, obviously, and this is our origin 0 comma 0. So what is the difference between 0 and v? 0 and v difference is v. What is the difference between this 0 and t? T, right? Now the slope is basically given by velocity by time, right? Tan theta is delta y by delta x, right? So this is the coordinate geometry. If you have remembered it, very good. If you don't remember it, I am telling you right now. So this is how you generally find the slope for a straight line graph. Now imagine the graph is not a straight line. So here velocity equals to s by t, okay, that is also a way. Now suppose the graph is not a straight line, it is a curved line. Now if I say find the slope in this point, at this point, now how can you find the slope? Okay, how can you find the slope in this case? So for that, what you have to do, you have to do something which we call is differentiation. Okay, so dv by dt. So dv by dt in physics means it is the slope of the graph. Now how can you find dv by dt? Obviously the velocity function required will be given to you. So this is a curved line, so this will have a velocity function. So velocity function, it can be anything, okay, it must be provided with respect to time t. So it can be at cube plus bt square plus ct plus d. So this kind of function will be given to you, and if you find the differentiation of this, you can calculate the slope of this graph, okay. And also sometimes we generally want to find small change. Okay, for example, you have a gas in a container, you apply a small temperature change, you want to find what will happen to its volume if the pressure is constant, right? So this kind of things you have done in your thermodynamics class. So whenever the change is small, you have to apply differentiation. For example, in this case, you have to take a small portion of dy, and correspondingly you have to find whatever is the corresponding change in x, and you have to find the dy by dx, which is the differentiation. Small change in y, say dy, and small change in x, dx. So for small change in dy, whatever is the change in dx, that is called the differentiation. So differentiation means basically normally if it is a function is given, it is slope of the graph. In some cases we also find the small changes in a quantity. Okay, and also it represents how rapidly something is changing. Okay, how rapidly a thing is changing. So if you take dt very small, how rapidly it is changing, that means how the velocity is increasing or decreasing in this case. So that also you get an idea from the slope as well as from the differentiation. So differentiation is required to first of all find the slope, secondly how rapidly it is changing, and thirdly in some cases how small what will happen if we change the quantity by a small amount, one of the quantity by a small amount. Okay, now for differentiation, this is those are the physical aspect of it, this is the formula aspect of it. You have to remember the basic formulas related to differentiation. So differentiating any constant will always give you 0. For example, if you are differentiating say ddx of say 5, now 5 does not have any other quantity, so the differentiation of any constant will always give you 0. Okay, we had a teacher in our class, he used to give us the marks if you do not correct a problem. So basically you are getting 0. Instead of that, he used to give ddx of c. How much marks you got? ddx of c. ddx of c means you got 0 in that problem, right? So ddx of c means 0. Now ddx of any x to the power term, okay, x to the power of term basically gives you n into x to the power n minus 1. What is the meaning of that? So that means if you are differentiating, so here basically we have I told you some functions, right? So 3x square, suppose we are doing it like this, 3x square. Now in this case this is a constant. Okay, any constant involved in the differentiation, it will be, if it is only constant, then it will be 0. If it is accompanying with some other function, if it is accompanied by some other function, for example here we have a company x square, so this 3 will remain as it is, this 3 will remain as it is. Okay, this is just a scalar multiplier. Now x square we have to differentiate. How can we differentiate x square? To differentiate x square, first of all, what is the power? We have 2. So that 2 will come out. Okay, and then x square was there, it will be just, you have to reduce the power by 1. So it will be 6x. So differentiating 3x square, you will get 6x. Now in some cases this will not be so easy. Some cases you will get at cube plus bt square plus say c. You have this kind of function and you are differentiating. Then what will be the answer? In that case, first of all you have to differentiate at cube. Same method. Okay, so a is constant, so it will stay as it is. T cube is there. T cube means first this 3 will come out, okay, and then t to the power 3 minus 1. The thing that you have to check is that if we have this t and this t are same or not. If it is t and it is not t, then there will be some extra term that you will learn in mathematics, not in this class, not today. Okay, plus b into 2t plus now this is a constant and it does not have any t term involved in this equation. So what will happen to the differentiation of this term? So this will give you 0. Okay, so you get 3at square plus 2b into t. Okay, so this is the differentiation of this term. Now some cases there will be some values will be given to you, and in most of the cases you have to equate it to 0. Okay, they will tell well when the velocity will be 0 or when the acceleration will be 0. So based on the problem you have to equate it to 0. 90% cases it will be equals to 0. 10% cases there can be some other values, but mostly it will be 0. Okay, so you have understood how to do the differentiation of the first case. Second case is something unique. So if you are differentiating ln x, it's the brother of log. If you have used log generally represents base 10. If I am writing log, then normally it represents base 10, right? Now if you write log with base e, then that is written as ln, okay, ln or ln. Now in physics this comes more often than log 10, so that's why this is very, very important in physics. Log we are not super interested, ln we are interested. So ddx of ln x gives you 1 by x. Okay, ddx of e to the power of x, e is a very nice function, exponential, right? Exponential function. If you are doing differentiation of e to the power of x, you get back exactly e to the power of x. Okay, differentiating sin x, you get cos x. Differentiating cos x, you get minus sin x. Differentiating tan x, you get sec square x. So these are also very, very important, especially sin and cos. Okay, tan maybe sometimes, but mostly sin and cos differentiation is very, very important. And this one, this is the primary 99% cases you will face this differentiation. Not as simple as that, but in the form of this. Okay, so this kind of differentiation will come 99% of cases, and 1% cases sin x and cos x, and very rarely e to the power of x of differentiation was there, but that portion that there was one concept involving this differentiation, but that is no longer part of the syllabus. So we will see that if that topic comes out, but this part is mostly no longer part of the syllabus, both of them. Okay, both of them they are linked with each other, so they are not part of the syllabus anymore. Tan x you might face very rarely. Okay, now let's move on. Next, as we are talking about some physics, so let's see one of the examples. An object is moving with x equals to t square plus 2t plus 4. Find the velocity of the object at t equals to 2 seconds. So you have to remember few of the quantities that we will discuss during our lectures, revision classes, etc. So velocity is basically, velocity is how fast displacement is changing. Displacement is given by x, right? So how fast displacement is changing with respect to time, right? So what is the measure of how fast something is changing? The measure is basically differentiation. If you differentiate a quantity with respect to time, you get the how fast the quantity is changing with respect to time. So velocity is basically dx by dt. Some people call it dx by dt, some call it dx dt. Now whatever your teachers, your college teachers are doing, so you can follow that. I say dx by dt, which is easy, right? Now dx dt or dx by dt is basically d by dt of the x. So what is x? X is this, right? So remember also remember that dx by dt, you can write this as d dt of x. This is another way to write d dt of x. d dt means d by dt. Okay, so d dt of x, obviously mathematically nothing changed, right? So if you write it like that and put the value of x over here, you get this as your answer. Now you have to differentiate it. Now 2t again plus 2 plus, now this is a constant, so constant's differentiation is 0. Okay, now in the question they have mentioned that find the speed of the object at t equals to 2 seconds, right? So here what you have to do, you have to put t equals to 2 over here, right? So here you get 2 into 2 plus 2, that is 4 plus 2, that is 6. Now in general, if this is given in say in meters, then you can write this as meter per second. So in physics, not only doing the differentiation, you also have to give the units based on the question. If it is given in centimeter, it will be centimeter per second. If it is given in kilometer, it will be kilometer per second. Per second, why? Because time is given as second. If nothing is given, you can write units per second. If no unit is given here, then here you have to write units per second. Clear? So this is how you use differentiation to solve problems in physics. Now we are doing about integration. Now in integration, there are two types of integration. One is indefinite integration, one is definite integration. Now in physics, you will always solve definite integration, no scope for indefinite integration. Now what is the meaning of definite indefinite? Indefinite integration means there is no limit as such. Definite integration means there is a starting point as well as there is an ending point. So starting point and ending points are defined. That case we call it as definite integration, and whenever the starting point ending point are not directly provided, that is called normal integration, which is basically opposite of derivation. Okay, so for example, why I say opposite of differentiation? Suppose I say d x of say time t gives you some value, say y. Okay, if you differentiate some quantity, you get another quantity, right? We have seen that some values we have differentiated, right? So here we can say dt equals to y into dx, right? Just cross multiplication. So dx come over here and dt is here, right? For simplicity, let me write it in the common form, dt by dx. T is a function over here. Okay, let me write in terms of like this, df. F is the function, some function, we don't know the function. Okay, some unknown function which is given like this. Okay, so df can be written as y dx. So integration is basically considered to be opposite of differentiation. That means, and the symbol of integration is this kind of s with middle portion extended. Okay, it's like an s, right? So it's like an s, but middle portion is extended and the top and bottom portion are slightly smaller than usual s. Okay. So this is how you write integration. Now if you integrate normally anything df, what you will get? If you integrate this side, you will get f. Okay, so basically integration of any quantity normal like this, you get that quantity back. So this is a differential, this is called differential. You just differentiate it, you will get the function back. And on the right hand side, because it's a multiplier, you cannot apply the same logic over here. You need to know the function y. Okay, so you get y dx, and here comes a constant c. Okay, here comes a constant c. Okay, the logic why this is coming, why it is like that, things you will learn in mathematics. I can simply say if you differentiate, the constant will give you 0. So there is a possibility that there is a constant c involved in it. So this is how integration works. Okay, this is the undefined integration, general integration. But the definite integration that we are interested in physics generally does not involve this constant. And we have a starting point. Okay, we have a starting point, say x equals to 0 till x equals to say 5. We will have some known values, known range, okay, where we are integrating this dx. Okay, so this is something that we are interested in physics. Now what is the meaning of this integration? So you have a same graph, similar graph, okay, and we want to do the integration. This is the function y. This is the function y. Y is this curve. There are some equation involved, right? Now, if you do the integration, what is this function f? What you will get? So the thing that you will get is the area under the graph. How? So this is say our x along x-axis, this is our y. Okay, this is the function y, and what you will get, you take a small portion dx over here, you take a small portion dx over here. Okay, and if you take, this is the function value of y in this range, this is the value of y in this particular range. So if you multiply y dx, what you are getting? You are getting this area. You are getting this area. Now if you start from this point and end at this point, that means basically what you are doing, you are dividing this entire graph into small portions. You are dividing this graph into small portions and then basically adding them. All such y dx, this integration sign is basically is representing sum of. Okay, if you take small such areas and if you take the sum of all such small portions, you will get the integration y dx. There is some definition of integration as well. There is a definition of integration using this summation symbol. Okay, that also you will study in mathematics. I am not going to discuss that. What I am here is to just give you the hint what you are doing. Many students sometimes don't understand what they are doing. They just do the integration, but they don't understand, so they sometimes forget. So here basically what you are doing, you are calculating the area under the graph. Remember, area under the graph you have utilized in some previous classes as well. So area under the graph is nothing but a definite integration, where you have, this is your starting point, this is your starting point, and this is your ending point. Okay, so here generally the lower, this is called lower limit. Lower limit basically is your starting point. Lower limit is your starting point. Okay, where you have started and where you are going to end. Start to end. So this is the limit. Sometimes in cases we do not need to start from here. We can start from any other point and we can end at any point. If it is given, you can calculate the area on that particular region of space. Okay, if the function is known, you can find the area under the graph using the integration. Now, similar to the differentiation, you also need to remember few of the integration formulas. Okay. Now, in case of differentiation, normally differentiation, if it is you are getting 0, right? Constant, differentiation of constant is 0, but integration of constant is not 0. Integration of a constant will give you whatever with respect to you are differentiating, that ax plus c. Now, as I said, in physics there will be some starting point and ending point, and in that case the c will not come. The c will not come. Now, just for one more thing I like to say, that suppose integrating starting to end, if you are doing, just some students also miss that, y dx gives you a function of x. Okay, normally without this, without the limit, if you are getting, this is obviously the mathematical condition, you are getting fx plus c by integrating this variable. Now when I say starting to end of the same thing, then what? What is the difference between this and this? This is a function itself. This is a function, whereas this is a value. This will give you a value. Okay, how to calculate the value? What you have to do, you have to put the upper limit condition first. Okay, this is just a number. This is a number. Okay, minus f of ending point. Okay, so basically when you are integrating, suppose you are integrating this one and the limit is given, say 0 to 1. Same thing, I am just giving you one example. You are doing this integration, you are doing 0 to 1. The function is ax. ax is this function ax. Okay, now upper limit is 1. So first you have to put a into, instead of x you have to put this value 1 minus a. Instead of x you have to put the lower limit value, that is 0. Okay, now a into 1 is a into 0 is 0, so you get the answer as a. So same thing, if you put a limit, the answer will be a. Obviously you can see based on the whatever limit we will give, the value of this answer will change, but you have to remember the general integrations. Okay, you have to remember the general integrations, and then based on the limit that is given for that particular question, you have to find that particular answer as well. Okay, normally this is also a very common integration formula. X to the power n dx, x to the power of n dx is equals to x to the power of n plus 1 by n plus 1 into plus c. In case of differentiation it was opposite, it was decreasing. If you remember, in case of differentiation, x to the power of n differentiation was what? It was decreasing, n x to the power of n minus 1, right? Power was decreasing and the factor is multiplied. Here in case of integration, the power is increasing and the factor is division. Factor is in division. Also the factor is not same as n, instead it is basically n plus 1. Okay, so this is the basic integration formula. These two you have to remember. Also you have to remember this is not valid, this formula is not valid for n equals to minus 1. This is not valid for n equals to minus 1. N equals to minus 1 means what? N equals to minus 1 means x to the power of minus 1, that is 1 upon x. We have a separate formula for 1 upon x. For 1 upon x dx, it gives you ln x. Okay, ln x, that is log to the base e. Now integrating sin x, you get minus cos x. Integrating cos x, you get plus sin x. So just opposite to that of whatever you are getting in differentiation. In differentiation, sin x was cos x but positive. Integrating differentiating cos x was sin x but it was negative. In the case of integration, sin x you are still getting cos x, but you are getting with the negative sign. Integrating cos x, you are getting sin x, but the negative sign is gone. So you have to make this basics chart, this basic formula chart on your study table, so that whenever you are studying, these formulas are embedded in your head. In mathematics there are a lot of other formulas you have to remember, but these are the basic formulas for physics. At least right now you have to remember. Integration, differentiation, I still think that some of you are still doing it and familiar with, but integration, it might come a little bit later, so you might struggle initially. So that's why at least these many formulas should be there in your desktop right now. If you are studying from computer, it should be there on your desktop wallpaper. If you are studying on a study table, you have to write it down and put it, paste it till you remember all the formulas properly. Okay, so now as I said, if you are integrating, you will get, if you are integrating one function, you are getting a new function. Okay, and once you have done, the meaning of this is basically upper limit and lower limit, g of b minus g of a. I already given you one example. Okay, so this is how you generally do the integration, and we will solve questions as well based on integration in future. So there you will see, especially in the second chapter of your second PU, voltage capacitance chapter, electric potential and capacitance chapter, we will solve some integration based questions. There you will see how to solve the questions. Okay, for now this much information is sufficient in my opinion. Okay, now let's continue with the, okay, we have one example question as well. This is taken from your first PU. Force acting on an object as a function of distance travelled is given by F equals to 3x square plus 2. calculate the work done to bring the object from x equals to 2 meter to x equals to 3 meter. So force is given, and force is not constant, it is a variable function. Force is a variable function. What is the meaning of variable function? It is changing with displacement. How you are changing the displacement, flow force is also varying. Now they asked you to find the work done. So this concept you have studied. So let's see. So small work done is basically F into dx. Right? I hope you have you remember this formula. Now to calculate the total work done, you have to do the integration of dw from the starting position to ending position. Some write it I to F, I am writing S to E. Easy to remember. So that is your total work done. So total work done is nothing but integration F into dx. Where is the starting point? Starting point is x equals to 2. Where is the ending point? Ending point is x equals to 3. Okay. Now, so 2, 2, 3. Okay. F, what is the value of F? F is 3x square plus 2 dx. Okay. Now in case of differentiation, in case of differentiation, what we have done, if there was a plus sign or minus sign, if there is a plus sign or minus sign, okay, you can simply divide it into two separate integrations. In case of differentiation also, we divided into two separate differentiation and we differentiated each term separately. Here also we will integrate them each term separately. So that is 2, 2, 3. Okay, this is a constant, it can come out of the integration. Okay, x square dx plus 2, 2, 3. This is a constant, so this will come out dx. Okay, integral dx. Now that integral a dx, I already showed it to you, that can be written as integration of a into dx. Now integration of dx is what? I already told you, this is just opposite, so it will be a into x. Right? Now this is the first problem, that's why I am doing it like this. You need to do it simultaneously and you have to shorten the steps over here. This is just because I am explaining, I am doing it like this. Okay, so 3 into, what is the integration of x square? Integration of x square is x to the power 2 plus 1 divided by 2 plus 1. Okay, and what is the integration of dx? Integration of dx is nothing but 2 into x, right? And the limit is x equals to 2 to x equals to 3. So this is the value of the work done, right? Now simplify this a little bit. So 3x cube by 3, 3 cancels, plus 2x, 2 to 3, that is x cube plus 2x, 2 to 3. Now how to solve it? First you have to put 3 in place of x in all the possible cases. So if you put 3 here, you will get 3 cube plus 2 into 3, and then negative minus of, now you have to put 2 in all places, 2 cube plus 2 into 2. Okay, so 3 cube is 3 is a 9, 27. So 27 plus 6 minus 8 plus 4, that is 33 minus 12. So it will be 33 minus 12, that is 21 joules. Again, in physics, unit is important, so you have to always be careful about the units. Okay, this is how you generally solve integration related problems. And in future, instead of doing it like this, you should be able to do it directly. Okay, so it will be 3x cube by 3, that is x cube, plus 2x to the power 2 to 3. So this is a single step problem. You have to arrive at this stage from here only. Okay, so once you can do that, then you will realize I have made an progress. Right now it may not be possible. Obviously some students are doing it, they are talented, but I guess my students who are watching this video are not that much talented. So if you are able to do that, definitely you are already ahead of rest of the class, right? So if you but those who are not able to do that, at some stage you have to reach at this stage where from here to here you should do it directly without much thought. Okay, if you reach that stage, that means you have made a huge progress. Okay, so instead of doing all these steps, so this is how you should measure your progress. Now let's move into the next topic, which is graphs. Okay, so graphs, many students generally struggle with graphs. Okay, you have done majority of graphs are done in PU1 classes, second chapter, motion in a straight line as well as motion in a plane, but graphs is still there in your PU2 chapters for some explanations, in some cases some extra processes as well. Okay, so graphs are there in your PU2 as well, not as extensively as your PU1 classes, but it is still there. Now basically let us understand what is the meaning of a graph. First we are doing equation of straight line. So here we have a straight line. Straight line is easy, right? If an equation is given to you, you can take any 3 points and you can draw a straight line. For example, if you remember in your lower classes, there was some ax plus by equals to c. This kind of equations was given to you. Then what you used to do, you used to write y equals to c minus ax by b. Now you put some of the values of x over here, 1 2 3 4 5, and calculate corresponding y and choose the values of y such that y is also an integer, and then you say okay, this is a point. Okay, this is a point, this is another point. Okay, and here we have another point. So based on these points you join them and you get a straight line. Some cases 2 points are sufficient, in some cases we used to take 3 points, right? This is how we generally draw the straight line. So basically that straight line, whatever straight line we have drawn, that straight line basically is this equation. So this is the equation of the straight line that we have plotted, right? Now in general, normal equation of straight line that we often face is this: y equals to mx plus c. Okay, it has some meaning. Okay, y should be alone, there should not be any coefficient involved with y. In case there are some coefficient involved, you have to make and you have to divide it, like we have done in this case, right? So this is the equation of straight line. Here this m represents the slope of the graph. Okay, what is the meaning of slope of the graph? I have discussed briefly in our previous video. Slope of a graph or slope of a straight line means whatever angle is made by the straight line with the positive x-axis, whatever is the angle made by the graph with respect to positive x-axis, and if you take tan of that angle, that gives you the slope of the graph. Okay, this is the slope of the graph. Okay, and this c represents the cross section. Cross section means whatever is the intersection with the y-axis. So this is the intersection over here. This intersection represents the variable c. This represents c. Okay, this one, this line. Okay, and this one is the angle theta. So m is this one, c is the intersection. You will study that in the geometry chapter. If you have not yet done so, then you will study it. Okay, I am not sure, based on your board and your syllabus, this concept comes in different classes. Okay, anyway, so this you will study, but you have to remember that this equation and formulas are still valid in physics as well. Okay, if you see some this kind of equation in your physics, then you immediately have to remember this is the slope, this is the intersection. Okay, Secondly, this is there is another way to write the equation by ax plus by equals to c. So if you see that power of x and y are 1, then that represents a straight line. Okay, and you can again calculate the this is not dash, by the way, this is power 1. So let me erase it so that the confusion is gone. So if the power of x and y is 1, then that represents a straight line, and it is a 2-dimensional line. 3-dimensional we are not going to discuss. This is a 2-dimensional straight line. Okay, from if you write this equation in this form like I have written over here, so you can say minus a by b into x plus c by b, right? You can write it like that. So from here, if you compare this equation and this equation, you can say, so the slope of the graph here is minus a by b and the intersection is c by b. Okay, and now this c and this c are different. This is, let me write it like this. So this c and this c are not same. Now this is the intersection form, slope form, and in physics mostly this form is important. Okay, now let us see if you know 2 points in a graph, which is more common in physics. Okay, you have 2 points given in a straight line, along a straight line. Okay, 2 points, obviously you can form a straight line, no issues there. Suppose we have a point here, say x1 y1, here we have another point x2 y2. Okay, and if you want to find the distance between these 2 points, the distance between these 2 points, so what will be this distance between the 2 points? Straight line distance. Okay, distance means obviously straight line distance, which we encounter more often. So the distance is given by square root of x1 minus x2 whole square plus y1 minus y2 whole square. Okay, now it does not matter you are doing x2 minus x1 or y2 minus y1, because there is a square involved at the outside. So the in relative positions does not matter. You can do x2 minus x1, you can do y2 minus y1, or y1 minus y2, does not matter, because it is a square term, right? So if you take out the negative sign, it will be anyway it will be positive. So the internal sign is immaterial. Some textbooks say x2 minus x1, some textbooks say x1 minus x2, does not matter, because it is a square term. So internal it will always be negative. One of them will be positive, one of them is negative, but which one is that is up to you. Okay, it does not matter, as long as difference is important. Difference between x and y is important. Okay, so this is the basic formula for calculating the distance between 2 points along a straight line. Okay. I think it is already written over here. So as I said, internal symbols does not matter. X2 minus x1 or x1 minus x2, it is immaterial as long as you do it correctly. Let's move on to the next part. Here we are going to discuss 2 important shapes which occur more often in physics. Most common is circle. Most common, you have seen this kind of structure, shape, right? Most common thing is circle. Now as long as there is a circle, you need to know what is the radius of the circle, which is very, very important. The radius of the circle is the most important quantity to define a circle. Okay, so for that you need to know the equation of the circle. Generally a circle is represented by x square plus y square equals to r square. Okay, here r is obviously the radius of the circle. So if you know the radius of the circle, you can directly write this formula, or if you can see this formula, you can say this is a circle with radius r. This is the circle passing through the origin. If it is not passing through the origin, the circle equation can be slightly different, but this is the general formula of circle passing through the origin. This is the easiest one, and I am not going to make it complicated. The next shape that you face often in physics is the ellipse. Okay. So ellipse is, obviously you have seen that in Kepler's planetary law of motion you might face elliptical shapes in future as well, right? So what is ellipse? Ellipse is similar to that of circle. As you can see, circle is perfectly same in all direction. Ellipse is not as symmetrical as a circle. Okay, so it is slightly different. The equation for ellipse is x square by a square plus y square by b square equals to 1. Okay, so a is called semi-major axis, b is called semi-minor axis. Okay, what is the meaning of semi-major axis? This distance is called semi-major axis. Okay, and this distance is called semi-minor axis. Okay, this is the basic formula of ellipse, and these distances are also important. Ellipse generally has two focus, one here, one here, that you will learn in mathematics. I am not going into that detail. But if in case of an ellipse, if what will happen if A and B are equal, if A and B are equal, then that becomes a circle, right? If A and B are equal for an ellipse, then that gives you a circle. Okay. Now next is parabola. Parabola can be of different forms. This is one of the parabola, this is another parabola. Okay, you will learn these two types of parabola in mathematics. Y is equal to 4x, y square is equal to 4x, x equal to 4a y square. So these are the two different forms of parabola. Another parabola that we are interested is the general parabola. This does not necessarily to be passing through the origin. It can not starting from the origin. It can be a general equation of parabola. Now in case of general equation of parabola, what is the general equation of parabola? It is one of the coordinate will be in square form. So if you remember, in straight line it was both the x and y coordinates having power 1. In case of circle and ellipse, both having power 2, and it was a plus sign. In between x and y there was always a plus sign. Okay, and in case of parabola, one of them is square. Okay, one of them is square, ax square plus bx plus c equals to the other coordinate, say y. So it can be like this as well, ay square plus by plus c equals to x. These are the general equation of parabola. Any one of them, based on the which equation you are considering, the orientation will be different. Okay, here we have like this, that can be like this as well. So based on which equation you are, this is this equation. Okay, this is the equation of parabola in this form. And if you take only this portion, zoomed in, if you zoomed in only in this portion, that portion is already known to you. So this is the thing that you have studied, right? You have studied this. A projectile launched at some angle theta, it is hitting the ground at some distance. What is this? This is a parabola. Okay, some students think that it is a parabola, one starting from this direction, one starting from this direction, two different parabolas, and they are meeting it here. No, it is a single equation. This is governed by a single equation, and you have already found that equation in your PU1 class. So go back to your PU1 class and open your textbook and find whatever was the equation of parabola. That is important for competitive exam preparation as well. So this is the projectile motion. Projectile motion is the equation of parabola. Okay, in some other cases as well, you might see parabolic motion. For example, a charged particle moving in a electric field or a magnetic field. In particular case, there may be projectile motion kind of thing might happen. Okay, but most common is projectile motion, where you have seen the parabola. This is the most common, and trust me, in all the competitive exams projectile motion related questions will be there, and for that you have to use the not only use the formula for projectile motion, in some cases especially NEET exams and JEE exams you might need to use the common formula for parabola as well. Okay, hyperbola, it is one of the least used formula in physics, but you may have seen this graph. Hyperbola, the common equation is x square by a square minus y square by b square equals to 1. So this is the similar to that of ellipse, but the sign is negative. Equation is almost same, the sign is negative, then you say this is a parabola. Now if this a and b are equal, if a and b are equal, then that is called a rectangular hyperbola. Hyperbola. Okay, anything that reminds you? Now this in physics, whenever you encounter it, you don't see this one. Okay, physics, because variables generally don't go negative. Okay, time, for example, time cannot be negative, pressure cannot be negative, volume cannot be negative. So that's why these portions we generally omit. You will only see this portion. Okay, in all the physics cases except some higher order physics which is out of scope for your class, you will see this graph only. Okay, there is another equation for hyperbola, okay, especially for physics, that is any variable x times another variable y, if that is constant, okay, then that equation, this is a equation of rectangular hyperbola. Now how you can convert this into this, that is a complete different derivation. You might see that in mathematics class, you may not see that in mathematics class, but you have to remember that when two variables are multiplied, okay, and if you plot them along x along x-axis, y along y-axis, and if you multiply them, if you get a constant, then that is also a rectangular hyperbola. Example, PV diagram, PV equals to constant. Okay, isothermal process. In that case, if you remember, PV diagram looks like exactly like this, right? That was a rectangular hyperbola example. Okay, now let's move on. Now let us see some other graphs, which is exponential graph. Exponential graph means any graph, whenever you are plotting a graph, you have to define the coordinates, right? In this case, suppose we have a graph y, how the y variable is changing with respect to the x variable. That is the basic idea. Okay, in some cases y can also have a square term, in some cases they do not have the square term. For example, in case of straight line, y does not have a square term. In case of parabola, y may not have a square term as well. So here in generally y is equal to the function of x is the graph. If you know this, you can plot the graph. Function you already learned, right? It is a continuous function. Now if this function is an exponential function, what is the meaning of that? Exponential function is e to the power of x. There can be some constant involved over here. If this sign of x is positive, we say this is an increasing exponential function, and the graph will look like this. So it will start off very slowly, it will increase, but increase very slowly initially. Okay, and as the values increases, the values quickly increases after some point of time. So from here on, the value quickly increases and it goes to infinity. Slowly it will go to infinity. Okay, and in case the value same function y equals to constant e to the power of, so this is y1, another separate function, y to the power of minus x. There can be some function multiplied in this x as well, okay, but generally I am not considering it for now. So here the function will start at a very high value. if you see the function starting at very high value and slowly initially it is coming down rapidly and then slowly it goes to 0. It is called asymptotically it is going to 0, right? So basically asymptotically means at infinity it will become 0. Okay, so this is the exponentially decreasing graph, this is exponentially increasing graph. Okay, there are some similarity with this graph, and if you know there are some other functions which also shows similar kind of behavior. If you know that those functions, please mention that in the comment below. Sir, I have studied it and I have found it. Please mention those functions if you know those functions. Okay. Now slope of the graph, I have already given you a hint during the differentiation explanation, right? So you have a random curve, okay, and you want to find the slope of the graph. Now slope is basically y is equal to mx plus c. Here m is called slope, but this formula is valid only for straight lines. If it is not a straight line, if it is a curved line, how can you find the slope? Obviously the slope of the line of the curve will be different at different point. Okay, slope will be different at different point, right? So for example, if you try to find the slope over here, what you have to do? You have to take, first of all, you have to draw a tangent. In this portion, obviously it's almost a straight line, so you draw a tangent which is almost a straight line, then take a small dy and corresponding dx. So this is dy, this is dx. So slope is basically given by dy by dx. Okay, now if you want to find the slope over here, this is almost parallel to the x-axis. So if you see that dx here is 0, dx is 0, but dy is 0, not dx. Dx is not 0, dy is 0. So if you consider this point, exactly the top point, okay, sorry, here you will see that this is a parallel line. Okay, so dy, that is the change in y, is almost 0. So dy is 0 and dx is not 0. Dx is finite. Okay, in that case the slope of this point is 0. Okay, slope of this point is 0, dy by 0. Similarly, in some case, if you find this point, okay, if you try to find the slope at a point where it is exactly meeting the x-axis, here dx is almost 0, dx is almost 0, but dy is not 0. So at this point, slope is infinity. Slope can be infinity, slope can be 0, slope can be a finite value as well. So slope, based on how the graph is plotted, different points will have different slopes. Okay, so the application of calculus you are learning over here. So normally if you know the change, delta x, and if you know the corresponding delta y and corresponding delta x, then slope can be written by delta y by delta x. Okay, but this is not always possible. So for that, what we do, we take the differentiation. And if you know the function, then this is the way. If you know the exact changes for this point, then you can use this formula as well. So whatever is given to you based on the correct order, you may need to find the slope. Okay, now next is another important quantity that is required, which is called area vector. It is a completely new thing. Okay, you have seen different kind of vector, x cap, y cap, j cap. Now onwards you also have to know area vector. Okay, what is the area vector? So we know that area, any area, this one or a random shape area, okay, is always a vector quantity. Area of a surface is a vector quantity. If you don't know, you should know right now. Area of a closed surface is always a vector quantity. Okay, now how can we say which is how to find the direction of this vector? Okay, so direction of this vector is considered to be normal, that is perpendicular to the surface at the point. Okay, now you can, if this is a surface, you can draw two normals, one outward, another one inward, right? So it is a 3D thing, so that's why I have taken the images, because it is very difficult for me to draw. So you can take a vector either outward direction or inward direction. Okay, so this is also area vector, this is also area vector. Now which direction to take? For that, okay, either you can use right hand rule. So if this is the direction, you can say this is outward, and some cases you have to take inward based on the certain situation. Based on the certain situation, the direction of area vector is being determined. For example, if you take a closed spherical surface, the area vector which was inside is not considered. Okay, the area vector which was inside is not considered. We always say that area vector is pointing outward. Not only outward, we say it is radially outward. Okay, it is radially outward. Okay, so based on the given surface and some cases given condition, we generally determine the area vector. There is no fixed such rule. If it is a closed surface, okay, then the area vector is always outside, coming out. Okay, if it is an open surface like this, both side there is no such close proximity. So based on the certain cases, okay, how some other variables are involved with it. For example, if electric field is involved, how it is involved, generally area vector is considered in the direction of electric field. Okay, at least with the acute angle, that is less than 90-degree angle. Okay, that is generally considered as the direction of area vector, right? As I said, it varies from application to application, but if it is a closed surface, it is always taken in the outward direction, not in the inward direction. Okay, I think it's almost over. One more, there is some formulas. Okay, you can take note of these formulas. These are the basic formulas of geometry and surface areas, etc. Area of a square, area of rectangle, area of a triangle, half base into height. This is very important formula, right? Area of a trapezoid. Area of a trapezoid is another interesting thing. What is a trapezoid? Trapezoid means two sides are parallel but other two sides are not parallel, then this is called a trapezoid. Okay, how can you calculate the area of the trapezoid? If you know the height of the trapezoid, then it is given by half into height times sum of the parallel sides. Sum of the parallel sides. This is also very, very handy formula. Okay, you may have applied it in some cases, but you may need to apply in many more cases. So this is the area of a trapezoid. Trapezoid is a very common shape where two sides are parallel but other two sides are not parallel. Okay, perimeter of a circle is 2 pi r, area of a circle pi r square, surface area of a sphere 4 pi r square, volume of a sphere 4/3 pi r cube, area of a parallelogram is base into height, area of a curved surface is 2 pi rl, volume of a cylinder pi r square l. So these are all the important formulas that you will face time and time again in your physics classes. Okay, so these do not ask your teachers whenever they are using the formulas. You should remember them and you should understand, okay, sir is applying the formula for volume of a sphere, right? That's why it is 4/3 pi r cube. So I hope you enjoyed today's session. It's a very good session. I enjoyed thoroughly. I hope you also enjoyed. And if you are watching our channel for the first time, don't forget to subscribe to our channel, and if you think that this video is helpful for you, then definitely like our video and share it with your friends, those who are not interested in PU1, or you know that you want to help your friend. Please share this video with them so that our channel can grow and you can also be successful in your future endeavor. I'll be back with regular classes from now on very soon. Till then, bye.